All right, let's take a look at this quite interesting question. We have 7 sec squared theta being equals to 6 tan theta plus 8. And we're supposed to solve this question. By solving, that means we're supposed to find an answer for theta. So we're supposed to find a theta value. And don't forget, the theta value here is ranging between 0 degree to 360 degree. So what do we have to do first? Of course, one of the first interesting thing you have to do is to ensure that you are bringing every of the trigonometry function to just one particular one. So you are either going to find a way to turn this to tan theta or you turn this one to sec squared. Whichever way, you have to make sure it's only one trigonometry identity that is being featured in the question. So the way to solve that is to make use of your basic identities. So, and I remember precisely that one of our identity is sec squared theta equals to 1 plus tan squared theta. So if I fix this wherever I see sec squared theta, I'll be able to turn wherever sec squared theta was to having just tan theta, which makes it quite easier to solve. So where I see sec squared theta now, I'll be filling in for 1 plus tan squared theta. Now, opening this bracket, we have 7 plus 7 tan squared theta equals to 6 tan theta plus 8. So what we do next is we try to bring every of the values to the left-hand side because this is already taking the form of a quadratic equation. And in order to simplify much better, it will be very good for us to bring in all our values to the left-hand side. So I'll be having plus 8, plus 7, then bringing this in here, you'll be having minus 8 equals to 0. Of course, this 7 minus 8 will be minus 1. So I won't be wrong if I wrote just minus 1 here. So looking at what we have here, this already looks so much like a quadratic equation. But for those that are not seeing it clearly, you will see it much better if I decide to fix in my x as tan theta. I do this so that every student can follow along. Of course, it's still very right if you decided to solve straight from this particular equation. But this is so that everyone can get the best clarification of what we're doing. So fixing this in, I will have 7x squared minus 6x minus 1 equals to 0. So this looks very much familiar to everyone. So what we have to do next is to solve this particular equation for x. And if we want to solve this for x, we have several methods, but what we'll be using is the factorization method. And to factorize this, all you need to do is to find a factor that works for this equation. And those factors will be 7 and 1, minus 7 and 1. So minus 7x plus x is actually the factor we'll be using. So finding this, we'll have 7x into x minus 1 plus 1 into x minus 1 equals to 0. What we have here is 7x plus 1 equals to 0 or x minus 1 equals to 0. So this brings us to a very interesting place where we can get our final answer. So from here, I know that my 7x is equals to minus 1 or x equals to 1. Crossing this to the other side, my x now is equals to minus 1 over 7 or 1. Don't forget my tan x was, my tan theta was what we called x. So that means I can write tan theta to be equals to minus 1 over 7 or my tan theta to be equals to 1. All right, this brings me to angle of any magnitude. Of course, if you go on to change 1 over 7 to decimal, we'll be having 0.1428. So tan theta equals to minus 0.1429 or tan theta equals to 1. So we have to make use of angle of any magnitude at this point because our values ranges between 0 degree and 360. Solving this using angle of any magnitude, I told you that the very first step to do is to find the initial theta value, which you'll be using subsequently. And I told you at this point, you will be ignoring whatever sign you were having. So in this case, I had minus 1429, but I will only be using 1429. And in this case, I had just 1, and I will be using 1. You will ignore the sign if it was negative. You will not be fixing the negative sign there at this particular stage. So if you go on to find the arctan of this, the value for that will be 8.130. So this is 8.130 degree. And when our theta was arctan 1, is actually 45 degree. So these are two different values, and we'll keep solving them differently. So after getting here, if you followed through on the video on angle of any magnitude, the next step to take is for you to go on to investigate the quadrant. The quadrant is what brings out your answer. All student takes calculus, and we have a negative sign here. So I'm looking for where my tan is negative. Tan is positive both in first and third, so it will be negative in second and fourth. So my quadrant of interest here is, in this particular side of things, is the second quadrant and the fourth quadrant. So, and for this other one, this other side where tan theta was positive 1, of course, this is positive 1. So my quadrant of interest will be quadrant 1 and quadrant 3. So I have quadrant 1 and quadrant 3 as my quadrant of interest. So we go on to solve those two and find out what our final answer will be. For quadrant 2, the rule there is 180 minus theta. So obviously I'll be having 180 minus 8.130 because our theta for this particular side of things is 8.130. And that will give me an answer of 171.87. So theta here is 171.87 degree. While for the fourth quadrant, the rule that goes on here is 360 minus theta. So I can go on to have 360 minus, my theta here is 8.130 degree. And that means my theta value will be giving me a value of 351.87 degree. So that's how we solve questions like this. For this other side now, our theta is 45. And since we are having quadrant 1 being featured, my theta here also will be 45 degree. Whenever we have quadrant 1, all we do is to just replicate whatever we have gotten here. For quadrant 3, our rule there is theta plus 180. And since our theta was 45, so we have 45 plus 180, which will give me the value of 225. So this is our value for theta based on this particular question. So we can go on to say now that our theta value, don't forget, this will not be included. I told you already that the quadrant is what determines what our theta value will be, not whatever we have gotten here initially. Until you investigate using the quadrant, you will not conclude on the answer. So in this case where we have investigated and we got our theta to be 171.87, that's one of our answer. We also got 351.87, that's another of our value of our answer. In this case, from our first quadrant, we got theta to be 45. That's another of our answer. And we also got theta to be 225. So in this case, that means we can conclude that our theta is equals to 45 degree. Our theta is also equals to 171.87 degree. Our theta is equals to 225 degree. And our theta is also equals to 351.87 degree. Those are the four values for our theta, which I believe we are able to follow through on what we're doing. So this is how you solve trigonometry equations. You have to, number one, understand your basic identities, all your identities, so you can easily transform your equation to a form where you'll be able to solve. That was the initial thing we did. And then after on, you go on solving. Sometimes you come across a quadratic equation, sometimes it may be a linear equation. But in whatever case, you just solve accordingly. And when you get to a place like this, where you have tan theta being this or this, you have to make use of your understanding of angle of any magnitude to solve each of the answers you have gotten. And when you solve them, you conclude on your answers by using a quadrant. So I really hope this video has been really helpful to you guys. I'm sure you should be able to tackle any question on trigonometry equations. Thank you guys for joining. I hope to see you in the next video. Bye bye.